So we're going to go through the next two sections, which are the last two sections of Chapter 8, the difference of two squares, which I'm just going to kind of shorten it as DOTS, dots. Now, in Section 8.4, that was the shortcut section, right? And if we had the two binomials that were the same exact things, only you had one plus and one minus, we ended up with a squared minus b squared. So for example, we have four examples here. X plus 7 times x minus 7. All you had to do was, the shortcut was, you take your first term and you square it, minus your second term, which is 7 squared, 49. You could FOIL it, but you'll realize that when you FOIL it, it kind of simplifies to that. Take a minute to do the next three examples and multiply those just to get your brain moving for FOIL. So there's the shortcut. Again, you're just squaring the first term minus squaring the last term. Now, what today's section is, for section 8, we are going backwards. We are given a difference of two squares, which is the DOTS, right? And then we're going to factor it into two binomials. Now, difference of two squares can only be a binomial. Take a minute. Why don't you read through the procedure down below, and then after you're done reading, kind of just skim through or scroll down to the bottom. So it's just three questions. And if there's a no at any point of these questions, then you can't factor it, okay, or you can't do this shortcut. So first question for this first example, a squared minus 49. Factor out the GCF. There is no GCF. Okay, check. Ask, is the first number a perfect square? Yes, this is a perfect square. The square root of a squared is a, right? The second one, is the second number a perfect square? 49. Yes, the square root of 49 is 7. And then the last question is there a minus sign in between? Yes, there is a minus sign in between. Therefore, the factors of these, I know, since it's a difference of two squares, one of them is going to be positive, one of them is going to be negative. My first term is going to be a for both, and my second term is going to be 7 for both. Okay? Let's try 25x squared minus 16. Okay, the first term, both 25 and x squared are perfect squares. 16 is also a perfect squared. So 25x squared, when I square root that, becomes 5x. The square root of 16 is 4 and 4. Since I have a minus sign in the middle, that means I have a plus and a minus. Now this next one, I have 27g cubed minus 3g. This one has a GCF. What is this GCF? It turns out that it is 3g. So if I take out a 3g, I have 9g squared minus 1. And so, okay, 3g, I'll leave that here for my next one, but I'll have two binomials. And now if I look at this, 9y squared minus, or 9g squared minus 1, 9g squared is a perfect squared, so that turns into 3g, since that's the square root. And then the square root of 1 is 1, since there's a minus in between. One of them is a plus and one of them is a negative. This first term looks like a 39. It's actually a 3g. Okay? Now, I'd like you to try these next ones here. These are going to be a little bit challenging. Please note that when you unpause it, I'm going to erase everything, and I'm going to kind of go through these questions. The square root of 64p squared is 8p, so I'm going to have an 8p on both. The square root of 121q squared is 121q, 121q. Since there's a minus sign in between, there's going to be a plus and a minus. It honestly doesn't matter which one it comes to. Now, this one, for a squared, what can you take out? you could have taken out a 4. So you have a squared minus 4. And then a squared minus 4. Both of these are perfect squares. And I end up with 4 times a plus 2 times a minus 2. X to the 4th minus y to the 4th. This one is kind of a special one because we have to the 4th power. X to the 4th, it is a perfect square because that can be split to x squared, and y squared, and y squared. One of them is going to have to be a plus, one of them has to be a minus. Now, here's a tricky thing. This guy right here is also a difference of two squares. It fulfills all the questions. The first term is a square number. The second term is a perfect square number. And then this right here is a minus. So this actually satisfies another difference of two squares, but this first one does not, because there's a plus sign. So this first guy is just going to have to stay x squared plus y squared. And then the second guy can be split again into two more binomials. X squared, the square root of x squared is x. The square root of y squared is y, x and y. And one of them has to be plus, one of them has to be minus. So this one is a little bit trickier when you have to the 4th power. Try this grouping method. When you group it, you get to this point, 7x squared minus 7 times x plus 3. The 7x squared minus 7 can be factored out. You can take out a 7 here. So 7 times x squared minus 1 times x plus 3. And then you'll notice that this x squared minus 1 is a difference of two squares. So this can be split into 7 times two binomials. The square root of x squared is x. The square root of 1 is 1. Put a plus in one of them, put a minus in another. And it turns out that that is my final factored version. So I know it can be a little bit overwhelming, a little bit confusing. We'll definitely practice when you get to class the next day. Let's turn to the next page. Now, this is section 9, which is perfect square trinomials. Now, if you remember, again, this was from 8.4. These were shortcuts. A plus b squared gives me a shortcut of a squared plus 2ab plus b squared, and then a minus b squared gives me the same exact thing, only I have a minus. Okay? Now, when we get an answer, these right here are called perfect square trinomials because the first and the last numbers are perfect squares, and there are 3 of them, so there's a trinomial. Okay, so if you kind of look at the bottom here, this first example, 16x squared plus 24x plus 9, you only have to look at the first and the third. The first question, is the first term a perfect square? Yes, it is. 16x squared, the square root of that is 4x. What about 9? 9 is a perfect square. It is 3, right? The square root of 9 is 3. And then this middle term now is the middle term twice the product of the square roots? So the square root of 16x squared is 4x. The square root of 9 is 3. And then we have to double it. So is 24x the answer to this problem? Let's see. 2 times 4 is 8. 8x. 8x times 3 is 24x. So yes, it is. And so this is what we call a perfect square trinomial. And so now we're kind of going backwards. Maybe we'll just jump straight into this first example. Okay, so we have 4y squared plus 12y plus 9. Okay, let's take this one. Is this... and honestly, just test it out. Okay, I know this is going to be it's a plus, so my two signs are probably going to be positive if this works out. Okay, so I'm always going to check my answer for this one. 4y squared, the square root of that is 2y, 2y. The square root of 9 is 3 and 3. Okay, now if this works out, then this should be my answer. So let's see, 2y plus 3 quantity squared. Now, if this is true, okay, so 2y and 2y, that works to get 4y squared. 3 times 3 gives me 9. If I take my terms, 2y and 3, 2y times 3, and then I double that, do I get 12y? 2 times 2y is 4y, plus 3 is equal to 12y. So yes, this does work out. So that is my factor. Those are my factors of this perfect square trinomial. Try letter B. Try it. Okay? And then actually let's bring that back tomorrow to class. I'm not going to really read through this, but I would like you to kind of take a few minutes to kind of read through it. It's just saying that a polynomial is completely factored when it is written as a product of prime polynomials, meaning this word prime means that it cannot be factored anymore. Okay, so that's kind of what it's saying. So take a few minutes, read that, and then let's scroll down. This example says factor each polynomial completely. If the polynomial cannot be factored, write down prime. So if you can't do anything, you just got to write down prime. So 5x squared minus 80. First of all, I can take out a 5, and so I have x squared minus 16. Okay, x squared minus 16. This is a difference of two squares. So I can split this up into two binomials. Those are my two binomials, x plus 4 and x minus 4. Can these be factored? No, they cannot. So this is my factored polynomial. Okay, so I want you to try 9x squared minus 6x minus 35, and then also try 2x squared minus 32, and bring those to class tomorrow. Now, if you scroll to the bottom, it says solve equations with perfect squares. We're just honestly doing the same thing. So, a squared plus 12a plus 36 equals 0. Now, this is the one where you have to take that extra step and solve for that variable. Okay, I have an a squared, I have 36, which is also perfect square. So, a plus 6 times a plus 6 equals 0. Now, do I get positive 12a? Let's see, 6a plus 6a for my inside, 6a for my outside. Yeah, that turns out to be 12a. Okay, so that's good. These are my two factors. Now, if they're the same factors, you won't actually need to give me both equations because both equations are the same. So you actually don't even need the second one. You'll just need this first one. Subtract 6 on both sides. My a is negative 6. So in this case, there's just one answer. Fractions. Wonderful. I'm sure we love fractions. But here I have y squared minus 4/3 y plus 4/9. Y squared is a perfect square. 4/9 is a perfect square, even though it doesn't look like it. Y squared can be broken down to y, the square root of y. 4/9, the square root of that is 2/3, because the square root of 4 is 2 and the square root of 9 is 3. So 2/3. Okay, now what would have to go in the middle here? I have a minus, so it needs to add to a negative, and it needs to multiply to a positive. So both of them have to be a negative. And again, let's just kind of make sure that if I were to add the inside and the outside, I get negative 4/3. Negative 2/3 plus negative 2/3 is negative 4/3. So that works out. And so again, they're the exact same thing, so I'm only going to give one equation, and then I'm going to solve for that. So if I add 2/3 on both sides, I get y is equal to 2/3. Let's turn to the next page. Now here's something really interesting. If you have x squared minus 25 equals 0, you can do the difference of two squares if you would like to, right? You can do x plus 5 times x minus 5 equals 0, and then you can get x equals -5 or x equals 5. Right? You could do that. Or what you can do is, instead of getting 0 on one side, what if I had added 25 to both sides? And if I add 25 to both sides, then I get x squared equals 25. And then what you can do, you can take the square root on both sides. The square root of x squared is x. The square root of 25 is actually two answers, +5 or a -5. Because think about it. 5 squared gives you 25, but also -5 squared gives you 25. And so this also gives us the same exact answer. So if you look at the bottom here, I have 5x squared minus 80. Just kind of solve it as if we're solving for x. Add 80 on both sides. And so I have 5x squared equals 80. And then divide by 5. You get x squared is equal to 16. And then you'll notice that it kind of works out nicely that they're both perfect squares. So the square root of x squared is x. The square root of 16 is a +4 or a -4. So those are my two possible answers for that one. Let's look at this second one here. I have a minus 10 squared is equal to 121. Now, I cannot add the 10 because of this exponent here. So what I can do is I can get rid of the exponent. How can I get rid of that? I can square root this whole thing, and I have a minus 10 equals, now this gives me two answers, a +11, or I can have another equation, a minus 10 equals -11. And then now I have two equations, and so when you go ahead and solve it, I get a is equal to 21 or a is equal to -1. This final example on the bottom right corner, if I square root both sides, I have x plus 3 is equal to the square root of 26. That doesn't work, so if you look up here, it says use a calculator to find an approximation. And the square root of 26 is approximately 5.1, so x plus 3 equals 5.1, and x plus 3 is equal to -5.1. And when you solve that, there you go. Since this video is already pretty long, you can read through the word problem and you could try it on your own, but I'll kind of go through it on the next day for classes. All right. Again, I know the notes were pretty long and it's pretty tough, but let's come back to class the next day and bring any questions.